Welcome back, my students, to chapter 6. The third topic is lipids. It means fats and oils. What are the lipids? Lipids are esters formed from tri-hydroxyl alcohol, what we call it glycerol, with 3 molecules of fatty acids. This is the structure of glycerol. As we see here, we have 3 hydroxyl groups, and this represents alcohol. It is 1 molecule of alcohol, but it has 3 hydroxyl groups with 3 fatty acids. Fatty acid are C double bond OH. We have 3 molecules of these fatty acids. These react with each other by removing H2O from each molecule. So this is OH with H, OH with H, OH with H. So how many water are removed? Yes, 3 molecules of water are removed. Now what are the rest of the compounds? Here we have CH2O, CHO, CH2O. So this is the same. From the fatty acid, we have to join C double bond OR. We have 3 of them: C double bond OR, C double bond OR, and C double bond OR. Now this group C double bond OO, we call it ester group. How many ester group? We have 3 groups here: C double bond O, O, and C double bond OO, and C double bond OO. You can write it COO, by the way. Now this lipid, we call it tri-esters. Sometimes we call it tri-esters because we have 3 ester groups. And also it's called the triglycerides because we have, this is the glycerides bond, and this is glyceride, and this is another glyceride because we have the glycerine or glycerol in this compound. So again, what are the lipids? Lipids are esters. So these are the ester group. Formed from what? From tri-hydroxyl alcohol. So it is 1 molecule, but it has 3 hydroxyl, what we call it glycerol, with 3 fatty acids. What are the fatty acids? Fatty acids are carboxylic acids with a long or short hydrocarbon chain. It is R, which is either saturated or unsaturated. Saturated means single bond between carbon-carbon atoms. Or unsaturated, it means we have at least double bond between carbon-carbon atoms. Ending with what? With the carboxyl group COOH. Go back again. Yes, this is the R, C double bond OOH. It is carboxylic acid. But here this is the R, this R. Maybe it is saturated or unsaturated. It is long or short. Ends with what? C double bond OOH. It is the same COOH. Here we have the example of the fatty acids. So look now. This is the end, C double bond OOH, and this is the R. How many carbon atoms do we have here if you count them? Yes, here we have 15 carbon atoms. 14 of them with CH2 and 1 of them is CH3. So you can write it again. CH3, CH2, how many times? 14 times. Then ends with what? With COOH or C double bond OH. It is the carboxyl group. As we see here, the bond between carbon and carbon atoms, all of them are single bond. Yes, that's why they are saturated fatty acids. By the way, the name of this compound is palmitic acids. So in this compound, yes, so if they are in the lipids, like them, so they are fat because we have single bond between carbon-carbon atoms. Another example here. Yes, what do you see here? Yes, we have double bond, and here we have double bond, and here we have double bond. At least if you have one double bond, so it is unsaturated fatty acid. This example for the acid, we call it linolenic acid. Yes, so this one represents the oil. Now, what are the differences between fat and oils? And both are lipids. Go back to the structure. So these lipids may be fat, may be oil. What are the differences between them? So, according to this R, if it contains single bond, all these R groups contain single bonds, so it is fat. If these R contain double bonds, so it is oil. So what are the fats and oil? The vegetable oil and fats are types of simple lipids. Fats and oils are similar in their chemical structure. If we go back to the structure, they have the same chemical structure, but different in what? In the type of the fatty acid. So it means the R. Now, here it is the comparison between fat and oil. Fat is solid at room temperature, but oil is liquid at room temperature. In the fat, it has saturated fatty acid, means single bond between carbon-carbon atom. But here we have in the oil, unsaturated fatty acids, means double bond between carbon-carbon atom. By the way, not all of them, at least you have what? You have one that is, represents the oil. Sometimes you have long chain fatty acids, more than 10 carbon atoms. Here sometimes we have short chain of fatty acids. So here the example as ghee or margarine, cheese, and the butter. Here we have the example corn oil, olive oil, and any type of oil. How many types of oil do we have? We have 3 types of oil: mineral oils, volatile oils, and non-volatile oils. The first one, mineral oil, we call them petroleum oil or paraffin oil or diesel oil. For the volatile oil, from the plant we have the clove oil and cinnamon oil. Non-volatile oils we have from the plant corn oil or cotton seeds oil or olive oil. From animals we have the whale liver oils. These oils, volatile and non-volatile, are lipids, but minerals oil, they are not lipids because they are from the petroleum. What are the importance of lipids? Lipids are the richest source of energy. When they burn, they produce twice or double energy compared to carbohydrates, proteins, because they have high percentage of carbon and hydrogen atoms. They are found in meat, fish, and grains. Some of lipids take part in forming the tissues, and some of them in synthesis of some hormones. What are the physical properties of lipids? They are insoluble in water. They don't dissolve in water, but they dissolve in organic solvents such as benzene or ether. they have low melting points. Reactions of lipids. There are two types of reactions. The first one, reactions on ester bond or ester linkage. The second one, reaction on the double bond in the fatty acids. We start with the first one, reactions of the ester bond. We have two types of this reaction. We call them hydrolysis of lipids, both fats and oils. They are hydrolyzed by the action of digestive enzymes or strong acids, forming fatty acids and glycerol. So this process, it is the opposite of the formation. They are formed from glycerol and fatty acids. So when they decompose, they give fatty acids and glycerol again. So this is the structure of the lipids, maybe fat, maybe oil. Different, as I said, according to the R. If you have different R's here, R1, R2, R3, no problem. Maybe they are the same carbon atom, maybe they are different. You have to break the bond. Hydrolysis, it means to break the bond between C double bond O and O. In the formation, we take O. Yes, we take H from the O. Now, in the hydrolysis, you have to return this H to the oxygen. And from C double bond O, we remove OH. And in the hydrolysis, you have to return this OH to C double bond O. Again, you have to break from here. Yes, with the bond between C double bond O and O, this is the ester group. You have to break this bond. Then add H to the O, H here, H and H. Look, you will get OH, OH, OH. So, in this case, okay, we will get glycerol. Then, add OH to C double bond O, so R C double bond O, OH. Yes, R1CO, it is C double bond O, and this is the OH that we added. R1C double bond O, OH, so this is the OH. And this is R2C double bond O, OH, yes, R2CO, OH. C double bond O, it's written here as CO, it is the same. And this is R3C double bond OH and R3CO, OH are the same, so we have three fatty acids. And glycerol, it is the opposite of the formation. We have another hydrolysis in the basic medium. We call it the saponification. Okay, so when lipids, oil or fats react with the strong alkali, such as sodium hydroxide, NaOH, it forms salt of acid, what we call it this soap. And the reaction here, it's not found because it's in another chapter and this year is cancelled. So you have to know only the name of the saponification. What does it mean? It means the hydrolysis of lipids in the basic or alkali medium. To give us what? Yes, soap and also glycerol. The second type of reaction, the reactions on the double bond. These reactions are called addition reactions. The first one, hydrogenation of oil. Hydrogenation, what does it mean? It means adding hydrogen. So unsaturated fatty acids are converted into saturated fatty acids by adding hydrogen in the presence of nickel as a catalyst. So in the oil, the fatty acid in the oil is unsaturated, means we have double bond. So this is the double bond. When you add hydrogen, you have to break the bond and add hydrogen here and hydrogen in another carbon, because this bond, yes, one end of the carbon atom and the other end of the another carbon atom. That's why you have to add hydrogen to this carbon and hydrogen to another carbon. As we see here, adding hydrogen changing what? Change oil to the fat. That's why this is liquid, but this is what? Yes, solid. Sometimes you call it solidification. So what does it mean, hydrogenation? It means adding hydrogen to unsaturated fatty acid changing to these saturated fatty acids. The second reaction we call it halogenation. The first one is hydrogenation, but here we have halogenation. Halogen, it means, adding iodine or bromine to the double bond of fatty acids. To add halogen, such as iodine or bromine. The color of the iodine or the bromine will disappear with oils, but not with what? With fat. That's why this reaction is used to distinguish between oil and fat. So look here, we have the oil double bond, means we have oil. If we add iodine or bromine, any one of them, it has a color. It is, brown color. Sometimes it's reddish brown color. When you add it to the double bond, the oil, so the color will disappear, because this bond between carbon and carbon is broken. This bond is broken and added what? Iodine and another iodine atom. So this reaction, if you have fat or oil, and chemically, how can you distinguish between them? How can you identify them? By adding iodine or bromine. If the color disappears, that means you have oil. If the color doesn't change, so it is for the fat. The last reaction, we call it oxidation or rancidity. This happens when the oil or the fat is exposed to the atmospheric humidity and high temperature. Compounds such as aldehydes, ketones, and peroxides are formed. It leads to spoil the oil or fat, changing their color, odor, smell, and taste. So what does mean rancidity? It is the spoilage of what? Yes, of oil or fat, and they change their color, their smell, and their taste when they are exposed to the high temperature or atmospheric humidity. Thank you for listening.